Lynn. Next, we're going to hear from Andrea, who currently works as a data engineer at better.com. So continuing on the financial theme, if you need to refinance your mortgage, you can reach out to Andrea and she can direct you to the appropriate resources. But Andrea will talk about, well, she can also give her own introduction, but she'll talk about data stories and the different ways of telling them. And then Paul will also jump in there to talk a bit more in detail about the Cincinnati project that he mentioned earlier. But take it away, Andrea.
Great, thank you. Yeah, so I think it's good like following conversation with what Abhishek just showed, because it's basically like after you finish a lot of that like work on the exploratory analysis and probably modeling, as well as like how you want to present your data. Yeah, basically the data story. So why do we want data stories? It's after that we want to have like a conversation with the data, and also it's a way of presenting the data and the results, and not just the data, it's like the whole story of what our results are and what are the key takeaways of the whole analysis. So something like I found it's very important to notice is like, even though we usually left this at the end, it's very important to have it at the beginning as well, like having, like start building the story, because even though you could have like great results, if you don't have a good data story, your results might seem not as good as if you had a good data story. So some useful questions before like jumping and putting some graphs in is like, you have to define like who's your audience, like who are you presenting that story, what are the key takeaways, what do you like, how does it link at each part of the story to like the complete story itself, and like what is your audience gonna do with it. Something I found like also in my experience, like there are like 3 parts of the whole data story, which I have found very useful to like start putting it in order. So first, like describing the whole context, what is the problem, then describing the methods, like what is the data, where the data come from, the different sources, and what methods you used, and then presenting results and conclusions. Also, in my experience, like what I found something useful is like writing up first the story. So writing it like in paper and letters, like giving a list of like, this is the story I want to build, and then start building on top of it, instead of just like dropping pictures and graphs and then building on top of that, because sometimes you won't be linking each graph to another one. So having the story written out and then like putting the different visualizations and pictures that can actually guide you through it. So I'm going to talk about these 3 different like stages. So the first one, like describing the context. I'm going to guide you through different example of the ESG project. So this project was in 2016, and we usually, when we think about visualization, we usually think about like data and numbers, but like for data story, I don't think that's the whole point of it. Like it's not everything. Like we can also think about like visualization in the way of describing the problem, describing the context, that usually like not always have some numbers in it, but it's very useful for describing like how the data and what's the problem related. So in this diagram, we have the problem itself was describing the whole process. The project was related to the government in Mexico, where they have a system in place for online citizens can submit any like request to the government, and the government has to answer to it. So this is the flow of how the system works. So first there's like a citizen sending a request and they get a confirmation email. Then there's like a help desk where they read the petition or the request, they accept or deny it based on certain rules. And then it goes to a particular office that routes it to the different federal agencies, or someone else responds to it. So making this diagram helped us understand which are the phases of the whole process we were actually going to work on, where the data like come from the different parts of it, and also help the partner understand like more in terms of our project and help understand the process as well. And this is just one type of visualization for the context, but there are other ways to communicate like complex diagrams, mind maps, pyramid, Venn diagrams that can be very useful at the beginning for showing more of the context. Then I'm talking about the Cincinnati like emergency system, like the optimization. This was another project, 2016 as well. And how we actually describe the problem in a visualizing way. So this is also very useful because you have a whole picture of like, this is a whole problem. We have 80,000 incidents each year. And these are our resources. We have 38 fire vehicles, 12 ambulances, and then the problem starts getting at here. So from the 80,000 incidents, we actually send ambulance to 40%. But 42 don't need transportation to the hospital. And 60% no initial ambulance is sent. But from that 60%, 30% were actually needed. So this helps us visualize where the problem is and where is like, this is the real problem. 29% of the dispatches are misclassified. And this gives us a visualized way of saying like, where are our opportunities to actually gain insights. This is another example, and this is more of explaining the whole model itself. So the first problem is we have students that could, this is like increasing on time high school graduation rates. So from here, we could have 10 students, which are visualized this way. And then we have, from the 10 students, we have one of them is a non-completer. Another one graduated late. So this will tell us from the 10 students, we have 2 of them that are actually not graduating on time. This is the problem itself, and it's very easy to visualize, understand. There's no need for someone to actually like guide you through the data, like more depth or more statistics. It's just like a very easy way to describe the problem and describe it to the partner as well. And then what information we get to the partner, we usually like to put it like on table, like something very easy to describe, like this is the data we are using for the model we're building, this is where it comes from, and this is just like some easy way of describing the process of the model itself. And then how the features are built, and then building the features, we will get a prediction on time or non-time. As you see, like you usually don't need to like write so many words. It could be very easy to like just guide you through a data story of what you're building, just making like simple visualizations and simple like comments to it, which, and then the model. And the model itself is just like, okay, for our partner, this is how we're gonna present our results. So for you, you will get eventually a score, and it's like actually yes or no, and good of tracking. Like this will help us understand what is the result of our model, how are we give it to our partners, and how we are evaluating it. Another similar way of explaining how the model actually works, this is from another project where this is related more with time. So from 2012 to 2014, we have different type of incidents. So we have like mental crisis, school programs, and all these different events. And we are actually at a time of like booking. So we want to predict if someone's actually like gonna have a warrant. So this is like very simple way of saying like, given these events, we want to predict this other thing. And sometimes it's very hard to put it in words, or like if we talk about machine learning with partners, they might just like feel they don't understand, or if we start putting like more complicated graphs, we can lose a lot of like people that don't really want to get into the technical details. It doesn't look technical, but itself is it's telling you a lot of the technical parts of your project. And another part very important is how we present results. So yes, once we do our results, we usually have like something in Python where we have like a bar plot or different like graphs. But like pasting just graphs itself won't let the other people know what actually you want to take out of them unless it's like extremely obvious. But I always find super useful to add words to your graphs, add like colors that describe like, this is the important part you have to take from here. These are like the numbers, put them big itself. So for example, here we have like adding comments to your graphs make it much easier for the other person to know what they have to take out of the graph, and also adding like a title that will like just summarize the big takeaway from it. This is like extremely useful for when you're building or when you're presenting a data story. And also, just like a small point of it, like on my experience, I also had like one part where I had to present it to someone that they already had the context. So for example, like jumping to the context might not make that much sense at the beginning, and especially for people that they are hard to like pay a lot of attention. So sometimes it's useful to start with the results or like the main takeaways to like catch their attention. And once they see like, oh, this is actually something that I might be interested in listening to, so I'm going to pay attention. And then you could show them how you actually get to the results. So it's another way. So as I described the 3 stages, that's like the main order, but that could always be shifted depending on how you want to like get the other people attention. So I'm gonna pass it to Paul to describe also like a whole data story project. Yeah.
Yeah, just another one more example to add to the cool series that Andrea already shared. So this was a project we did with the World Economic Forum on trying to detect which ships in the ocean are involved with illegal fishing. That was the objective. So trying to predict the likelihood of being engaged in illegal fishing per ship out there in the ocean. You know, as with every project we just discussed, you start with data exploration. And I think nobody mentioned it, but it's always kind of undervalued, right? So nobody really says, I'm so excited to do some data exploration. I want to do training a model and I want to, you know, do some deep learning or something. But actually data exploration, if you're doing that, it makes you an explorer. So that actually should make it more cool sounding. But anyway, so if you go to the next page on there, because I think you're on the buttons. Yes. So this is a visualization that actually kind of makes me feel like an explorer as well, just because it's a map. But what you're looking at here is basically the visualization of all locations, location observations that we had for all ships across the world for 1 year. So these are just points mapped onto obviously grid, and it shows you know, a couple of cool things. So first of all, it's beautiful, right? So it's a nice way to look at your data, but it also shows a couple of things because it, you know, these are this for us was a data set that was a little bit hard to understand. We got 140 million data points, which were individual locations for these ships over time. And we just wanted to get a sense for, okay, where are these ships moving? Because we're trying to figure out, are they doing illegal fishing or not? Before we could even answer that, you know, where are they? Where are they? Obviously on the oceans. And what's interesting here is that they, what you look at here is you see kind of a map of the world, but we didn't include land borders here in this data set. So they kind of emerge from these ships patterns because obviously ships don't drive over land. And so you can see even some rivers emerge, and you can see some highways of the ocean. And this was sort of a first step in trying to, for us, have some you know, information emerge from the story. Now, the second piece we did was actually look at, if you look at the next page, just look at the ships that self-identify as fishing vessels. So lots of those other dots you saw on the previous page actually were you know, cargo ships or tugboats or other kinds of vessels, and that doesn't mean they automatically engage in any fishing. So they're, you know, ships actually self-report as being fishing vessels or not, and so then you see a smaller subset. And then a couple of things should catch your eye, and you know, maybe you've already noticed, but there's not, you know, let's say the highways or those big thick lines, the highways of the ocean have sort of disappeared, and that makes sense because fishing vessels will, you know, are more likely to stay on one location at a time, or at least they not go from A to B in a straight line. And if you flip back and forth, maybe between the previous slide and this one, you can sort of see other things, right? So look, for example, at Australia, which on this picture, the first one, which includes all data points, has a very nice coastal boundary. And if you go to the next page, you can sort of see that disappear. And that's interesting, because the reason for this is that a lot of countries, in particular Australia, but also others, have enforced their nautical border, right? So there's a border at the ocean, and that means that you kind of patrol that line and don't let any fishing vessels that you don't control enter your coastal waters. And Australia has really strong enforcement. And so all of a sudden, it looks like there's a buffer zone around Australia, which is basically the enforcement zone for that country. And a lot of the Southeast Asia, all those land borders also disappear. And then there's a couple of other interesting things. And I'm just telling you this because, we were going through this, and this is what the data stories really is, right? The data story is not just visualizing the data. It's about asking the questions, about exploring, about investigating what you're looking at. And what you see here is that there's a couple of interesting, on the left side, interesting white blobs, right? And even in the center of the picture. And you might wonder, what is that? There's no countries in the middle of the Atlantic, but these are basically marine protected areas. So these are areas like national parks around islands. And that's where you're not even allowed to move if you are a fishing vessel. So that's why they're basically white. And so as you start looking at this kind of data and visualizing it, hopefully you can see some things emerge. Now, there's generally, when you look at your data and explore it and tell these stories, there's two ways to go at it, right? One is the macro, and you do something like this, or you look at the entire data set, look at distribution, visualize it on a map. The other one's micro, where you actually look at, what does one person in my data set look like, and follow them throughout that trajectory. And if you look on the next page, you can see a little bit more of the micro analysis, right? We actually picked some of the ships for which we had also satellite imagery. So this, I'm skipping a little bit here, but we had not just location information, also satellite imagery. And all these red dots on the map are individual ships that show up on this satellite imagery data set that intersects with the positional data set. And you can all of a sudden see some of these ships emerge. And one thing that you should always keep in mind is the data that you're looking at or working with has never, ever been collected for your purpose. So you kind of think that actually you're working with this data and everyone collected it for you to do machine learning. It's never the case. Right? It's often done for audit reasons, for logging, some other stuff, but never done for machine learning. And this was a case in point where we actually wondered, why are there all these red dots near land? And you might not see that because you think there are red dots near the ocean or in the ocean, but actually it's not true. They're all in ports of some islands. And the reason for that is satellite image providers don't collect images over the ocean because they can't sell that data. They only provide images or collect images over land. And so these are all these kinds of stories that you start seeing as you're trying to, in our case, detect ships over the oceans for illegal fishing. Actually, the data doesn't contain a lot of images. So that could be a challenge. If you go to the next page, there's other ways to visualize it, like in heat maps. So you look at a port and see when other ships went to that port. You can skip to the next page. Here's another visualization. We looked at the Torres Strait, which was an area where basically we did have access to higher quality imagery, and also here there were a lot of ships captured over the ocean. Which you can see on the next page. You can actually see them moving down the ports, which for us was a big finding because these were not automatically available. And then, and this just becomes nice because you could even use this as a training set where you've got images with ships in them that you can then use to train another model that will detect images that you don't know that there are ships in them yet. And then the next page here shows one more of those micro analyses, right? Looking at two specific ships and tracking them all, throughout time. Where they went over the period of a year. And, this was all in our exploration phase useful because we could test whether if you report that you're a fishing vessel, are you actually doing fishing, or the other way around, if you're a cargo vessel, do you engage in what looks like to be cargo-like behavior, cargo vessel-like behavior. So, because of course, if you're doing illegal fishing, you might report to be a cargo vessel because there are reasons to obfuscate what you're trying to do if you're doing it illegally. which again comes back to, you know, understanding the quality of your data. So this is just another example of how you want to, you know, bring together some of the exploration and visualization to tell a data story.
Thanks so much, everyone, for all these shares, and thanks to everyone who joined. Please remember to, as Andrew would say, smash that like button and subscribe on the YouTube channel and join the Slack channel and the conversation there. Please feel free to reach out to us beyond these webinars. And come back in 2 weeks when we will be talking about building solutions. So once you've gone through all of this work up front, understanding the data, how do you build a solution, whether that solution is going to be a predictive model or a dashboard or something in between. Anything else to add?
No, I think that's it. Thank you so much, everyone, for joining. Thank you to all our presenters, and we'll see you on Slack.
Yeah, thanks everyone.
Bye.
Keep exploring.
Take care.